What?
I did the chapter 3 and chapter 4 ones last night. Then Grace bothered me.
I was trying to get the probability homework done last night.
Were you successful?
Barely.
Questions about anything before we get started?
No, it was in the videos. I kind of forgot to say. I didn't write it down.
Annuities.
Oh, for heaven's sake. Okie dokie. What was in the videos was about annuities. Did you watch anything? The next several chapters all have videos up for 11. I mentioned this on Friday.
You did.
I didn't realize we were all the way to chapter 6 already.
I watched them back in the room.
Thank you, Ziddy.
Now that you say that, I remember you saying
You 100% did say
I know I 100% did say
Grace,
it.
I'm pretty sure you even made a comment about it too.
What's that?
Like more homework? I wrote it down in my homework book too.
I did not write it.
It was just in really small lettering because I couldn't fit it next to all the other homework.
You know, seeing if flipping the class a little bit helps with learning theory of interest stuff only works if you actually help flip the class.
I would have watched them if I knew, but I wasn't.
You could have watched the video though on YouTube that it goes with the class and you would have known.
I was having fever dreams all weekend.
Fever dreams, that what you said?
Yeah.
That's not
scary. It's a scary weekend.
All right.
Next joke. Weird question. Can you whistle? Can you whistle like a loud whistle?
I can't do that one. I can whistle loud enough without doing that, but. Hey!
Grace, where did that come from?
I don't know. I was just thinking about it.
She said it was weird.
I don't remember what. Oh, because I was blowing into this. It was kind of making a whistle sound. I was like,
You
huh.
put grass between your thumbs that does that.
Yes. I've tried to do that too, and it doesn't work for me
I
either.
suck at that.
I can
I've
do
tried.
That one? I can't do that one either.
I can almost do it, but it's quieter than my like actual.
Or this one?
I can't even write it whistle.
Oh, I got it!
Oh, hey, good
That
job.
was good.
I'm glad this is all getting recorded.
I can't do that one.
It's effective use of class
I
now.
can't even do this one.
We're always effective.
All right. Let's go through at least a little bit. So for Wednesday, make sure you watch the videos. All right, anyway, let's go through a little bit about deriving one of the formulas for annuities, and then we'll do some problems with annuities, and we'll talk a little bit about the calculator. So let's remind ourselves a little bit about geometric series. That was one of the first videos that you would watch, was a review of geometric series, right, Sid?
Yeah.
Yep, see?
The R.
Yes.
Yeah, I didn't need
I
that.
didn't need to watch
That's
that
why I
video.
didn't watch the video.
I
What is
probably
it?
did.
Go up there and write it down.
Yeah, come on, Haley. Haley's gonna put her head down. No habla inglés. All right, anyway. So, geometric series, we can do finite or infinite geometric series. You will see both of them pop up in problems. So, the geometric series infinite case comes up from the finite case anyway. So let's just talk about where it comes from in general. Let's start with this. If I tell you to take 1 plus x and multiply by 1 minus x, what do you get? Minus x squared. If I say do 1 plus x squared and multiply by 1 minus x.
1 minus x squared minus x cubed.
Isn't it just like the 1331?
We get a 1 plus an x squared minus an x squared minus an x cubed. So what happens?
Minus x cubed.
What if I do 1 plus x squared plus x cubed and multiply by 1 minus x?
1 minus x is 4.
Hey, look at that.
We're doing so good.
So if I take 1 plus x squared up to x to the n minus 1 and multiply by 1 minus x.
1 minus x to the n.
Yeah, 1 minus x to the n. Good. How would you prove that? If you were going to prove it, how would you prove that formula? What proof technique from discrete would you use?
Proof by contradiction.
No,
proof by induction.
By induction, yeah. Don't remember how to do that? Well, that could be a problem.
Brute force.
All right, so you can do it by induction. That's how you would prove this particular formula. All right, so the geometric series part comes from this piece here. So if I solve for this, as long as x isn't equal to 0, this will work. I can solve for this and get that the sum from I equals 0 to n minus 1 of x to the I will be 1 minus x to the n over 1 minus x. Thing to remember, at least the way I remember this, is make sure that your series starts at 1, and then when you find your common ratio is what that typically is used, or typically what that's called. Once you find your common ratio, as long as it starts at 1, then you know that this power on the x is just 1 higher than the highest one you see in your sum. So this is the sum of a finite geometric series, and when I do these problems, if I have to do one that actually involves a geometric series, or I don't have a special formula and I'm not necessarily able to use the calculator, I make sure that I factor out a common factor if I need to make sure my series starts at 1 before I do anything else. Okay, so that I can use the formula directly. And that way I don't have to try to re-index anything or any of those kind of things that you might do in, say, Calc 3 if you're doing things with series. You might have to re-index some things. There's re-indexing when you've done adding in. So I try to avoid that when we do these particular problems because all of the problems are going to be very, very similar. So you can always factor out a common factor first and then just use the formula directly. All right, so this, by the way, there's no restriction on x except that it cannot be 1 because I had to divide both sides by 1 minus x. For this particular formula, there's absolutely no restriction on the x. Okay? For this to work. Now, when you go to the infinite case, however, you have to be careful. If I let my n go off to infinity, the idea, of course, behind the geometric series is that as n gets bigger and bigger, what do we want to have happen to this term here? Go away. We want it to go away, right? We want to get that smaller and smaller. If my x is bigger than 1 or less than negative 1, that's not going to go away. Right? So in order for this formula to work, if as n goes to infinity, I need my x, the absolute value of x to be less than 1. So we know that if I do the series from I equals 0 to infinity of x to the I, this will be 1 over 1 minus x if my absolute value of x is less than 1 to make that x to the n piece go to 0. All right, so where does this come in as far as financial math goes? Well, everything that we've done so far has been either a single payment at a given time or just a few payments at a given time, and then try to find a present value or an accumulated value, right? But what we're going to be interested in this particular chapter is annuities. And what we mean by this is that we're going to have regular payments made into some account. Now, for our purposes right now, regular means each period. So if you're going to make regular monthly payments, that means you're going to put in a payment at the end of each month, or perhaps at the beginning of each month. Those are slightly different concepts, but we're going to do end of each month or end of each period to start with. If it's quarterly payments, it'll be the end of each quarter. If it's yearly payments, it'll be the end of each year, so on down the line. You're not going to miss any payments, is what I mean. And they're all going to be evenly spaced. Okay? All right, so let's say you wanted to figure out what the present value is first. Well, let's say that if we draw a time diagram here to start with, let's just say to start with, we're going to make a payment or make a deposit, whichever you want to think of it as. We're going to have a payment of 1 at the end of each period for n periods. And we want to know what the present value of this payment stream is. That's the idea. Oops. Oops, probably can't see that. So if I'm looking for the present value, where do I need to pull all of those payments back to? Hand signals. I got to pull them all back to time 0, right? I got to pull this first one back to 0, the second one back to 0, and so on down the line. So if I want the present value, what's going to be the present? What would I need to do to the 1 to bring it back to time 0? You need to discount it. What letter do we use for discounting?
D.
Well, D is the discount rate, but for discounting we use the V, right? V is 1 over 1 plus I. Okay? So that first one is just going to be a V, right? 1 times V. We agree with that? I got to take the payment of 1 and move it back 1 step. How about this one? If I move it back 2, what do I need to multiply that by? It'd be V squared, right? And the third one? V cubed. And all the way to the nth one?
B to the N.
V to the n, right? That's moving each of those payments back to the appropriate number of time periods to get back to time 0. We agree? Does this look like a geometric series?
Where's the 1?
Yeah, exactly. Where's the 1? Okay. So this is what I was mentioning last time. Typically when I think about a geometric series, I'd like it to start at 1. This one doesn't, but I do see a common factor of V. Right? So I should be able to factor off the V. And now I've got the 1 plus V squared all the way up to V to the n minus 1. And that fits our formula nicely for geometric series, doesn't it? What does that series add up to? One minus V to the n over 1 minus V. We agree? And now we can simplify this a little bit. Remember that V is 1 over 1 plus I, right? So I can write the V out in front as 1 over 1 plus I, and the V, I'm not going to write the V on top as 1 over 1 plus I, but the one on bottom I'll write as 1 over 1 plus I. If I distribute the 1 plus I through, Notice I'll get 1 plus I minus 1, and the denominator I'll just simplify to I. So this becomes 1 minus v to the n over I. So this is how we find that the present value of this payment stream. Now this has a special symbol because of course it does. We read that as A angle N. Absolutely no idea why. That's the notation. That's how it's read. I haven't done enough reading on the history of actuarial mathematics to know why it's A angle N. I don't know why it's A. Especially don't know why it's A for present value because you think you're using A for accumulated value, but my guess is that these things were developed in a language, originally developed in a language other than English, and that's probably where the abbreviations came from.
Does this be an I written to me?
Yeah, I was going there. Yep. Yeah, so A angle N, notice in this particular problem that the I is the same all the way around, but if you're unsure or if there's more than one interest rate flying around, on the outside you typically write the I, what the interest rate is. Most times you won't write the little I in there because there will only be one interest rate in the problem. So if the interest rate is understood, you typically don't write it. But you're exactly right. You did watch the video. Yeah. Yeah. Cool. All right. So this is how you do present value. This particular type of annuity is what's referred to as an annuity immediate. So the annuity immediate means the payments or the deposits or whatever it is are made at the end of each period. There's a different name for ones that are made at the beginning of each period. And we'll talk about that in a minute. But let's see if we can do a problem. I'll try to pull one of these off to start with. Without it being too nasty to start with. Maybe. No, I was going to. I'm looking at these. Let's see. Well, let's just look at on that past exam questions, sections 3D to 3F. Start with that one. Maybe not necessarily the easiest one to start with, but we'll do it anyway. Let's look at number 1 on that. This is sections 3D to 3F. Probably could have pulled out the big packet and found an easier problem to start with, but I already said this one now, so we'll do it. If for no other reason than it'll give us another formula in a minute here. All right, so it says to accumulate $8,000 at the end of 3 N years, deposits of 98 are made at the end of each of the first N years and 196 at each of the next 2 N years. Let's start with that. Let's just start with the Let's just start with the 98s. So we got 98, end of the first year, second year, all the way up to the nth year. Where do I want to move all of those 98s to? To the 3n, right? I want to move it up to the 3n because we want it to be 8,000 at the end, right? So we need to take this block and move it up here. I'm going to do it in 2 steps just so that you can think about another way to think about this particular problem, because we can do this from what we just talked about a minute ago. I can take this 98 and calculate its present value. What would be the A angle N I in this case? Well, remember the problem for the A angle N I, that's 1 minus V to the N over I, right? We agree with that? What were the payments in this case, though? When we came up with just this formula, what were the payments being made? 1, right? What are the payments now? 98. So instead of having 1s here, I had 98s here. What do you think we need to do to this formula to talk about the present value of just the 98s? Multiply by 98, right? If we think about up here, back with our formula, we can think of the 1s being here, right? You agree? Think about the 1s being multiplied by all those. Well, there's not any change, but what if these just other payments, right? As long as they were the same, I could factor it out. Agreed? Okay? So, going back up here then, the present value of the payments of 98 would be 98 A angle N I. That would be the present value. We agree? Okay. Now, of course, this one's a cumulated value. So instead of doing it to the present value, what I probably should have done was figure out what the accumulated value was here, and then move that forward. And there's actually going to be another way we can look at this in a minute. I want to kind of look at this in different ways. But right now, if I have the present value, this is present value, right? How can I take this present value and move it forward 3n? What would I do? If I wanted to take the whole thing, what can I do?
Multiply it by 1 plus I and the n.
Good. Yeah, I could take the present value and multiply it by the 1 plus I to the 3n, right? So you could take your 98 A angle N I and multiply it by 1 plus I to the 3n. We agree with that? So, in particular, I'm going to go off on a tangent here. I'm allowed to in math class. I can go off on a tangent. Never made that joke before. Never.
See it on a shirt.
See there a shirt somewhere. But I'm going to go off on a tangent here. Notice that to get from the present to the future, we just multiply by this future piece, right? So when we developed the formula for present value. Well, you could also get future value. What did we do? If I want your A angle N, I, and move it forward n units, n time units, this would be your accumulated value, which is abbreviated S angle N. This is the letter they use. So this one again is present value of an annuity immediate. This is future value of an annuity immediate. Oops. And notice there's not a lot of, there's nothing really new here. All we're doing is taking a present value and accumulating it with interest, right? Right? So there's not anything new here. It's just with new symbols and new formulas. However, from the formulas that we have, we can come up with a formula for your S angle N. We know the S angle N I. I guess I forgot my I again there. This 1 minus v to the n over I is your present value of the annuity immediate. And then I would multiply it by 1 plus I to the n. Well, what do you know about 1 plus I and v? What are they? Reciprocals, right? So if I take v to the n and multiply by 1 plus I to the n, what's that going to turn out to be? 1, right? So this just simplifies to 1 plus I to the n minus 1 over I. Yeah, Grace.
Why did you multiply S by the 1 plus I to the n?
I didn't. I multiplied A angle n by 1 plus I to the n. I'm trying to take the present value and move it to the accumulated value. So if I have a present value, I just need to move it forward in units, and that's how we do that by the 1 plus I to the n. That's our accumulation factor with the compound interest. A lot of times you'll see the two formulas written, you'll see the present value and the future value, but if you know the present value formula, you can always get the future value, right? So you don't really need to memorize two formulas. You've got one, you can get the other. Save that brain space for something else like the, I don't know, when Beyonce has a new album drop or something, you might want to store some more lyrics in that spot.
Yes.
All right. So anyway, does that concept make sense though? How we can move from one to the other? And that was, like I said, that was the concept that we did over here, right? We took the present value of the 98s and moved it forward 3 n time periods. That's one way we could have looked at it, right? There's another way to look at this. There's a lot of times there's multiple ways we can look at this. It said 1240 on my watch. I'm like, holy cow, I'm talking really slow. There's multiple ways we can typically look at a lot of these different problems. Right now, I was going to break it up as the 98s and the 196s and look at it that way. I'm going to talk about a different way here after I'm done with that. But are we okay with this so far? Do you have a question, Sam? No, okay. All right, let's look at the 196s. Let's go back up to our time diagram. We also have the 196s here, right? We agree? We take those 196s and move those forward. Notice those start at time, the payment started n plus 1, but I want to think of this as an annuity immediate. That n plus 1 has to be the end of a time period, right? So really we're starting at time n, correct? You agree? Okay. So what's one way to think about moving those 196s forward? Oops. Okay, let me ask you this question instead. Could you tell me what the value of those 196s would be at time n? if I wanted to think about the 196s, this, oh, hey, this whole thing swung, this whole thing moved on me. If I wanted to think about the value of these at time n, what would the value be at time n?
The AV that you just computed.
Well, the accumulated value had to do with the 98s. That's going to be separate. I'm just worried about the 196s. Okay, let's ask me this way. If I'm asking you for the value at time n rather than 3n, if I'm looking at a value at time n, is that going to be an accumulated value or a present value computation? Present, because I'm moving things backward, right? We agree? So since this is an annuity, I'm probably going to use an A angle something, right? And I don't know what I is. What goes under the angle? It's the number of payments, right? That's what goes under the angle. How many total payments are we making?
2n.
2n, right? We agree? Okay. So that would give us the value right here at time n. What would I need to do with that then to get it to where I need it to be? Where do we want to move that to? 3n, right? So we need to take the 196 times A angle 2ni and multiply it by what?
PV.
1 plus I to the 2n, right? I got to take that present value and move it forward 2n years. What's another name for, without the 196, what's another name for this expression? That's the S angle 2n, right? We agree? All right. So we know that at time 3n, these two accumulated values need to be equal to 8,000, right? Or together they have to be equal to 8,000. So I would have 98 A angle n times 1 plus I to the 3n plus the 196 A angle 2ni times 1 plus I to the 2n. The sum of those two things has to be 8,000. We found the two accumulated values. Pardon me. We found the two accumulated values of the payment streams. When we take the sum of those two things, we have to get 8,000. That make sense? All right, now we should be able to solve the problem. What was the formula for A angle n again?
1 minus Vn. Oh. 1 minus.
Yep. And then this is times the 1 plus I to the 3n, 196 times 1 minus V to the 2n over I, times 1 plus I to the 2n. They give you some other piece of information in the problem, don't they?
Yes. 1 plus I to the n is 2.0.
I don't know why they put the 2.0, but yeah, it's 2, right? They tell you that 1 plus I to the n is 2, correct? So what will 1 plus I to the 3n be?
6.
And I have to pull the exponent out, right? So it'll be 2 cubed will be 8, right? 1 plus I squared will be 4. What's V to the n? 1/2, right? Because remember the V and the 1 plus I are reciprocals? So b to the n will be a half, b to the 2n will be a fourth. We agree? Okay. Does that look like something we can solve for I? I think it does, doesn't it?
Well, there's no problem.
Well, it's in the denominator. So let's see, what do you get here? You get 98 times 4 is what? 392. And over here you get 196 times 3, which is what? 588? If I did my arithmetic right?
Did you just multiply both sides by I?
I multiplied both sides by I, and then I was simplifying the arithmetic. This one should be 98 times 4, right? There's a half times the 8 will give me 4. 98 times 4, I believe, is 392. I did that right. This is 3/4 times 4 will give me 3, so if I multiply that by 3, I get 8, carry the 1, 8, carry the 2, 5, 88. You should always check my arithmetic if I'm doing it in my head. Heck, you should always check my arithmetic if I'm doing it on a calculator.
Let's see.
So what do you get for I then if you solve? 12.25? Cool. Like I said, maybe not the easiest example to start with, but it illustrates a couple of things. One was about the present value and the future value. And just because you're using present value doesn't necessarily mean that you're moving something to time 0. Right? If you're doing a present value with an annuity immediate, it means that you're moving it to the period, the beginning of the period where your first payment is being made at the end of the period. So that 196 was at n plus 1. If I do the present value using annuity immediate, we get to time n. And then the idea of being able to take that present value and just moving it forward rather than memorizing formulas necessarily. You can memorize the SN formula. It's not bad. It's just there are lots and lots of formulas to remember. And the idea of moving money around should be fairly straightforward. I said there was another way that you could have thought about this problem to start with. This way of thinking about it will help later on when we start doing things that have increasing and decreasing annuities. So it's one of the reasons why I want to go ahead and talk about it. The problem is that you had 98 for the first n years and then 196 for the next 2 n years, right? Well, another way to think about it is that you really do have 98 all the way through, don't you? I can think of one of the income streams, or one of the payment streams, as 98s all the way up to 3n, right? Now, if I think of it this way, what did I split the second income stream into? I've already pulled out a 98, so there's another 98 starting at n plus 1, right? We agree? So I can think about taking this payment stream and moving it to time 3n, and taking this payment stream and moving it to time 3n. Right? So the first one would be 98 S angle what? If I take the long one, the S angle 3n. And the second one would be 98 S angle 2n. Good, yeah. We agree? And you'll get to the same place. You'll get the same answer. Well, you better. Or you did something incorrectly at some point. But you can think of it this way as well. And this idea of splitting a payment stream into two different payment streams pops up later. So the reason why I wanted to kind of go through it this way. Plus, it gets you set up pretty quickly. and well, from a formula standpoint, these are nice formulas, right? This one okay? Everybody's thrilled to death. All right. See if we can do a slightly easier one. Let's take out the big packet.
Wait, you're going to show stuff on the calculator.
What's that?
You're going to show stuff.
I am going to show you something on the calculator. That's why I want to go to an easier one. And I wasn't seeing an easier one right away off of those, so. Me. There goes. All right. So we got our handy dandy calculator on here. Let's just look at the first problem on in that chapter 6 exercises. 4-year annuity immediate with annual payments of 100 and an effective annual interest rate of 9%. It asks the two parts ask you to calculate the accumulated value and to calculate the present value. So both of these we can do with the time value of money buttons, the white buttons again on your calculator. Remember again, before we do any of those, we want to clear the time value of money in case there's any old values in there. Okay. All right, so to do accumulated value, we're going to assume that there's nothing in the present value to start with. We'll add in payments and then calculate the future value. Okay. So in this particular problem, the payments are what? 100. So we'll hit that for payment. I/Y again is your interest rate per period. Now, the problems will get more complicated as you go along. We want to make sure that the interest per period, the period part matches when the payments go in. So you might be given an interest rate for a different period than you get for the payment period, so you'll have to make some adjustments, and we'll talk about those as we get to those problems. But in this case, we're making annual payments and having an annual effective interest rate of 9. So we'll hit 9 and put that in our I/Y. It's 4 years, so 4 will go in for N. Again, we want accumulated value, so the present value should be 0, and we'll compute then the future value. We can get 457.31. You should be able to compute that with your S angle N formula and get to the same spot. If you do 1.09, was 9 was the interest rate, right? 1.09 to the 4th minus 1, and then divide by 0.09, multiply by 100, you should get the same answer. It's just faster than typing that formula every time. You're going to get that one? Again, notice that we put in 100 as positive and it gave us future value as negative because it's thinking of if you're getting $100, then you're going to be paid back the $450 at the end or something along those lines. It's just opposite of, to set things equal, things about money going in, money coming out idea.
So it's the right answer, just the wrong side.
Yeah, it's the right answer. It's just the wrong side. All right. If you want to do the other way around, let's declare the time value of money again. We still would do the 100 for the payment, the 9 for the interest rate, the 4 for the number of periods. In this case, we'll want to compute the present value and get 323.97. And again, you could do this using the formula, your 1 minus v to the n over I. It's just a little faster on your calculator.
It's unrelated to this.
Okay.
For number 3, what is the A, what are the 2 dots?
We haven't talked about that yet.
More symbols?
Yeah, there's more symbols. We just haven't talked about that one yet. It's not a big deal, I promise.
Is it annuity due?
It is annuity due, yes.
Watching these videos.
If you're watching the videos, you probably would have known, yes. This one okay? All right. We'll do more problems next time. We'll also talk about I only got 2 minutes, so according to my watch. Actually, according to the computer, I got 3 minutes, but that's not worth the effort to try to go through another problem. So we'll do more of these next time. Please watch the videos if you haven't watched the videos, Haley, Grace, Sam, Martha. Maybe a little less time.
I won't be here. I gotta go try to pass exam fee for the third.
Good luck on that.
What are you gonna turn in the homework this week?
I'll stop by them tomorrow and get them. Or I can stop by before I leave for right now.
All right. Wow. I think you touched a nerve.